My talk is pretty close to time, so I think we should probably get started so we don't run over. I don't really have a warning for this in my talk, but I just realized I should probably mention, because I forgot to, if you're a beginner to programming or a beginner to Python, this is going to be a whirlwind of a talk. You are probably going to struggle with this because object-oriented programming is tricky in general, and I'm just kind of diving into some pretty advanced class things. So I'm hoping you'll get something out of it. If you don't, if you do, either way, please give me feedback afterwards because I want to know what this talk was like for you and your experience level. So before we begin, I'd like to quickly introduce myself. So my name is Trey, and I help Python and Django teams onboard new teammates and turn their front-end developers into full-stack Django developers. I also teach a lot of core Python fundamentals for non-Django teams. I run a Python exercise subscription service as of January this year, where I send out one Python exercise every week in order to help people improve their Python skills. This is from non-beginner to even more non-beginner, hopefully, at Python-specific concepts. It is called Python Morsels. So we are going to talk about classes. I would like to talk about making classes that are easier for developers to use. Now, I'm really, really tempted to use the phrase Pythonic classes to describe this idea, but that word Pythonic is a loaded one, and it's a somewhat controversial one at times. So I'm going to instead call these friendly classes. Friendly classes are friendly for the developers who use them. Friendly classes have a nice string representation. They can be compared to each other, to other instances of that class, in ways that make sense. And whenever it does make sense, they overload operators to make themselves addable, iterable, hashable, or other types of operations that might make sense on those classes in Python. So we're going to take a look at two examples here. The first example of a friendly class is a month class here. These are contrived examples, but they're examples. If you want a class in Python that accepts attributes, you probably are going to need an initializer. You can make that with dunder init. If you want to have a helpful string representation, you'll need a dunder repr method. Dunder, by the way, stands for double underscore. Double underscore methods are special methods that provide a contract between you and Python to make some functionality. We're going to see a lot of those. If you haven't seen them, you're going to have to look these up later. If you wanted your class to be comparable to other classes using equality and using inequality, you need to implement dunder EQ. Dunder EQ is for equality. If you're in Python 3, you get dunder NE, not equal, for free. In Python 2, you've got to implement both of those. This is a Python 3 oriented talk, so I'm going to kind of leave that one out. We're only doing dunder EQ. If you wanted to go further here, and you wanted to make your class sortable or orderable, you'll need to implement the less than operator using dunder LT, the greater than operator using dunder GT, the less than or equal to operator using dunder LE, and the greater than or equal to operator using dunder GE. We've just ballooned this class. We now have lots of methods for each of these individual comparisons. So after all of this, we've not even written any code. Our class is already looking pretty heavy. If we implement the code for this class, it would look something like this. So you might notice that there is a lot of code duplication here. All 5 of those comparison dunder methods are pretty much the same method. They have very similar code. The only real difference in each of these is the operator that each of them uses. Now, there's a helper in the Python standard library that can make this a little bit shorter. It is called total ordering, and it lives in the functools module. Total ordering allows us to implement just 2 of these comparison operators, and it'll implement the other ones for us automatically. So here we've chosen to do dunder EQ and dunder LT, and it kind of automatically figures out the other ones from those. Now, we still have a lot of boilerplate code here. This class, in fact, is mostly boilerplate code, but it did help us shorten this class implementation. So we're going to take a look at an even better way to do this later. I'm going to kind of skip over that and leave that till the end. First, we're going to look at another example. So this example is a class that represents a 3-dimensional point. So x, y, and z coordinates. Just as in our last example, we're going to want a class that accepts arguments, has a friendly string representation, and allows us to compare it to other points. What if we also wanted our class to be unpacked into 3 coordinates using multiple assignments? So saying x, y, and z are equal to our point, and we can unpack those coordinates automatically. So what this means, unpacking these coordinates, is that we are really asking if our class is iterable. If we support multiple assignment, our class has to be iterable. To make our class iterable, we need a dunder iter method in order to do that. This is a little bit advanced. Now, I've done a talk on iterability before. There's a lot of talks out there about this, but multiple assignment relies on iterability. So we need a dunder iter method for this. Now, in this particular case, you might also decide to make your class immutable, meaning that you can't override attributes once you've made them. It might make sense to say that assigning to x is actually an error. We don't want to be able to assign to our attributes after we've created a new point object. For this, we have to make a custom set attr method, dunder set attr. Now, this is even more advanced than our dunder iter here, but it does work. So if our class is immutable, it should also be safe to use our class in a set or as keys in a dictionary. If you've ever tried to use a class in a set or keys in a dictionary, you might notice that it doesn't always work. You need dunder hash for that to work. Now, all of this is great. It makes our class friendly for someone who's using it, but for us, the developer, the person who made this particular class, this is a lot of work. So after all of this work, our class is going to end up looking something like this. So this class actually does quite a bit with very few lines of code. Some of this is probably new to you. I'm almost certain that for most of you in this room, some of these things here are new. For example, if you haven't seen yield before, you can Google generators and iterators. That's a generator that we're making there. You can Google how to use those on your own. This is basically code copy-paste time here. If you need a class like this, copy-paste this class, and you've got a start to that. Instead of memorizing all this, we could just copy-paste this class and reformat it whenever we need it. While a lot of these things are probably new to you, this code is pretty succinct. It's pretty short. Even if you don't entirely understand it, at least it doesn't take up a lot of space. We shouldn't have to type it all out every time, though. This is something that you shouldn't have to copy-paste. You shouldn't have to type out. This is boilerplate code. This is code that shouldn't need to exist. It should just work. So fortunately, there is a tool that is in the Python standard library, not our functools.totalordering, but another tool that will do all of this work for us. It's called NamedTuple. This is in both Python 2 and Python 3. The NamedTuple function, it lives in the collections module. NamedTuple isn't a class, it's a function, but it is a class factory. What I mean by that is when you call NamedTuple, you pass into it the name of a class that you would like it to magically create for you and the attributes that that class should have on it. And it will dynamically create a new class for you, not a class instance, not a class object, the whole class itself it makes on the fly. The class, the classes that are created by NamedTuple have a friendly string representation, like the one that we're looking for in our own classes. They can also be compared to each other using equality and inequality, and they're immutable, meaning we can't change attributes on them after they've been created. That's something we get for free. You can't change that, so if you don't want it, you're stuck with it. And they're hashable, meaning you can use them in sets, you can use them as keys in a dictionary. So out of the box, NamedTuple pretty much gives us all of the things that we were looking for in our point class here. Not our month class, but in our point class. The way that NamedTuple works, though, might seem a little bit unintuitive. It's a function that gives us a class back, which is not something you usually see in Python. As of Python 3.5, there's an even better way to use NamedTuple. Instead of using collections.nametuple, you can now inherit from typing.nametuple. Typing.nametuple is a class which pretty much does the same thing. So while collections.nametuple is a function that creates a class for you, typing.NamedTuple is actually a class that you can inherit from to make a NamedTuple. It looks like a class. It gives you a class back. The NamedTuple class pretty much gives you the same thing as that NamedTuple function. It looks different, but you get mostly the same end result, except that we can use type hints when we're defining our attributes, x, y, and z. So if you haven't seen those, that's a Python 3 specific feature of using that colon to kind of hint at what the type of this thing is. Also, one thing that you don't get with the collections.NamedTuple is you can set default values. So we can assign all these to 0 by default if they're unspecified. That doesn't really make sense in this particular example. It's a little bit weird to set all of those to 0, but it is handy at times to be able to set default values when making NamedTuples. So in general, NamedTuples are pretty great to get something that's like a tuple, but a little bit more descriptive. That's like a tuple, but even better. But if you're using NamedTuples to replace a class that doesn't necessarily need to work like a tuple, you might want to be careful when using NamedTuples. I want to show you why that is. So NamedTuples inherit from tuples, which means they inherit all of the features that tuples have. So they can be ordered, which doesn't necessarily make sense for our point here. Asking 2 points whether one is less than the other is kind of nonsense in this particular case. So this can be useful that they are ordered, but you get this by default and you're stuck with it. They can also be added to each other. But the thing you get back when you add two NamedTuples together might not be what you'd expect. This is not the object we were looking for. So be careful when you're using NamedTuples, because also if you multiply NamedTuples by an integer, this works as well, but again, you get something a little bit unexpected. So this is a little bit odd. Now, NamedTuples have a length, but again, this is a feature that doesn't necessarily make sense for our points here. So NamedTuples are a great replacement for tuples, but they are just that. They're a replacement for tuples. They're not necessarily good for everything. So they're useful, but be careful when using them. Now, if you do want to fix these problems manually, you could overload all these different operators and raise an appropriate exception to make sure they can no longer be added or multiplied and all that type of stuff. But finding and removing features that you don't want is often trickier than adding features that you do want. So I wouldn't recommend this. If the features of NamedTuples are inappropriate for your use case, you probably shouldn't use them. One alternative to NamedTuples is attrs. Attrs is a third-party library that makes it easier to create classes that have certain common features. This is really what we're looking for when creating friendly classes. This is more appropriate than NamedTuples oftentimes. So the way that attrs works is you have to pip install it. It is a third-party library, so you've got to go grab it from the internet and install attrs on your machine. After you've got attrs installed, you can import attr. Now notice there's no s there, which is a little bit odd. You pip install attrs, you import attr. This bothers me personally, but it works. And then you decorate your class with attr.s, which is a little bit silly, but it works. So this attr.s decorator, we are passing the auto attribs argument. What that does is it allows us to use type hints, which is pretty nifty. It looks kind of like that typing.NamedTuple that we made there. By default, attrs classes get a nice string representation, just like NamedTuple, just like what we're looking for. And they can be logically compared, meaning we can use equality and compare these things to each other. But they can also, like NamedTuple, be ordered, which again isn't what we're looking for. We've got to figure out how to disable this feature because it doesn't make sense for these 2 point objects to be asked the question, are you less than or greater than each other? So our point objects can be ordered, which isn't a good thing, and they aren't yet iterable, meaning we can't use multiple assignment with them, and they aren't immutable, meaning we can change them, and we shouldn't be able to set that x variable after we've made this point. So if we want our point class to work just like the one that we made manually earlier, we could do this. So what we've done here is we're using attr.s, but we're setting frozen to true. We're making a frozen object, which means our attributes can't be modified after we've made it. We can't assign to the variable x. We've also added a dunder iter method to make our objects work with multiple assignment. Now this is the same dunder iter method as the one that we implemented earlier manually. You don't need to understand how it works. You can just copy paste it. And we've disabled comparison operators. We did this so that we can't use less than and greater than. Now, because we did this, we need to implement dunder EQ, which we no longer get for free, unfortunately. And we need to implement dunder hash if we want hashability. So already this is a little bit of a pain to be turning off and turning on features and having to figure out what to re-enable manually. Now, the attrs library, it is more powerful than NamedTuples, but it does sometimes take a little bit of playing with to get things right. Also, it's a third-party library, which means that you have to pip install it to use it. If for whatever reason you can't pip install things on the machine that you're on, you're kind of stuck. So there's something similar to attrs that's actually bundled with Python. It's called dataclasses. Dataclasses is essentially a simplified version of the attrs library, and it's built right into the Python standard library. To use dataclasses, you'll import dataclass from the dataclasses module, and you'll decorate your class the same way we did with attrs. The syntax relies on type hinting, just like with typing.nametuple and with attrs. The point class that we get back from this has a nice string representation again, and it does support comparisons, but it does not support ordering, which is what we're looking for. This point class does not yet work quite the way we want it to, though. Iterability and immutability, these are two things we've been discussing here. It doesn't support either of those. If we want both of those features, we have to do something manually. So if we want to use our point with multiple assignment, if we try to do this right now, we're going to get an error. We cannot unpack this point object into x, y, and z. Also, if we try to assign to the variable x, it works, which is not what we're looking for. We want this point to be immutable, meaning we shouldn't be able to change these attributes. So we're expecting to get an error here, and we're expecting to not get an error in that first case with that multiple assignment. So we need to make our point class iterable and immutable. So for iterability, we can implement a dunder iter method, the same way we did before. So you can copy paste this from the class that we made earlier. Instead of hard coding the self.x, self.y, and self.z, there's actually another way to do this with data classes, though. We can use asTuple. The data classes module has an asTuple, which is a helper function that allows us to get a tuple that contains our object's attributes. So we don't have to care about is it x, y, and z, x, y, or something else. It just works. So this is kind of nifty, especially if you're trying to write generic code. So our point class now, it is iterable, meaning that we can use multiple assignment with it, which is great. But it's not yet immutable, meaning we can still change its attributes. To make it immutable, we can set frozen to true. So very similar to attrs that we saw earlier. So when we set this frozen attribute, what we end up with is that if we try to assign to a point object now, as we're expecting, we get an error. We cannot assign to these attributes. It is now frozen. It is immutable, meaning it cannot be changed. So our class is iterable. It's immutable. It's comparable. It has a nice string representation. It's not orderable, and it doesn't have a length, which are good things. And it doesn't have other features that don't make sense. We haven't opted into things that might end up making a bug in our code, like plus or like multiplication, that type of stuff. So using data classes, we have made a friendly class for someone to use that has exactly the features we're looking for, and we've done it in less than 10 lines of code. I think this is pretty cool. So when I told you before that data classes are included in the Python standard library, I was telling the truth, but what I meant was that data classes are included in Python 3.7. Who's using Python 3.7 currently? Okay, that's a few of you. Good job, people who are early adopters. Python 3.7 was released about a month ago now, so you're probably not using it yet. If you're not using it, fortunately, data classes is also available as a third-party library. So you can pip install data classes and start using it today as long as you're in Python 3. If you're in Python 2, you're out of luck. Data classes, unfortunately, does not work in Python 2 because of that type hinting stuff. If you do need Python 2 support, or if you need more features than data classes actually provide you, you might want to reach for the attrs library instead. Data classes was actually inspired by attrs partially. The PEP that added data classes, it had discussion about attrs because it predated. It was a pre-existing technology that data classes was inspired by. So personally, I would reach for data classes. If you need a little bit more or need more support, reach for attrs. Okay, so I'd like to take a look at some common uses for data classes for making friendly classes. Now, I'm intending this section to sort of act as a recipe book for how to make different types of friendly classes. I don't mean it to be an infomercial for data classes, but it might be an infomercial for data classes. So I apologize in advance. You can try to use attrs with these as well. It works with a lot of these. So without any customization at all, data classes give you a good string representation for your object. They allow objects to be compared to each other with equality and inequality. And out of the box, without any customization, these are pretty much the features, the main features that you get that you'll reach for. As I just showed you, it's also possible to make your data classes immutable by setting the frozen attribute to true. This makes it so that we can't assign to any of the attributes in our class once it's been constructed. Once we've got a point object, x, y, and z are set in stone. And as an added bonus, setting frozen to true also makes your class hashable, meaning that you can use it in a set or you can use it as keys in a dictionary. So we could use our point as a key in a dictionary and set some kind of data along with it that is tied to that point, which can be pretty handy. This is something that it's often handy to do, is use your objects in a set or in a dictionary. So normally data classes aren't hashable because it's usually a bad idea to make a mutable object hashable. I'm not going to go into why that is. You can talk to me about it afterwards, but you can turn on hashability without freezing your object, but just don't do it. I'm not going to show you how to do it. If you do have a case for doing it, maybe we'll talk about it. There's sometimes good ideas or good reasons to do it. So we've already seen that if we want to make a data class iterable, meaning that it supports multiple assignment, they don't have any notion of this. Data classes don't understand iterability, but you can always do it yourself by making something iterable using a dunder iter. So you can implement your own dunder iter method. They do have a helper as tuple that makes that a little bit easier. One thing that I haven't shown you is how to make your data classes orderable. So what I mean by that is like what we had with our month class earlier. So we had a month class before we talked about data classes, NamedTuple, or attrs, and it was orderable, meaning we could use the less than operator and the greater than operator on that class. Now, data classes don't support ordering by default, which is good in the case of our point class. If we want ordering, though, we can actually enable it by setting order to true when we decorate our data class. This makes our class order items lexicographically. That is a word you've probably never heard before. I say it pretty much every time I teach a Python class, exactly once. What it really means is it's a fancy way for saying the way that Python normally orders lists, tuples, strings, and pretty much any other type of orderable collection, that's lexicographical ordering. You can look that up, but ordering works the way you would hope it would work on data classes when you set order to true. By default, you can customize it. What if we want other operations on our data class objects? So for example, we have a vector class here. What if we wanted to be able to add together two vectors or subtract two vectors? Now, similar to iterability, data classes don't understand these notions. These are left up to us to implement. So if we want to make our class friendlier, we want to be able to support addition and subtraction, we have to do this ourselves. We have to implement dunder add and dunder sub, which gives us addition there where we can take two vectors and add them together, and subtraction. So here the way we've implemented dunder add and dunder sub is that we're looping over our vector instances. We have two vectors, ours and another one. We're looping over their attributes and adding each one of them together individually. And then we're making a new vector from them. We're using a little bit of fancy trickery there with that asterisk and such. You can look that up on your own, but it works. This is pretty short, and the reason it's short is our class is already iterable. If we can loop over the attributes in our class, it's pretty easy to implement these helper methods. So Slightly friendly classes make it easier to make even more friendly classes. Okay, so I have a section here that I know I don't have time to get into, so I'm not even going to try. Also, I probably shouldn't get into it because this is kind of advanced. So I'm going to skip over these slides here. There's probably about 5 sets of slides because I don't have time, and I don't want to confuse you all. I'm a little bit confused by some of these features, honestly. I will tweet out a link to my slides afterwards so you can look through these slides here, these advanced recipes on your own. The word metadata is in this slide. That's scary. Before we wrap up, I'd like you to consider whether you even need classes. So I just gave you this talk on classes here. I'd like you to take a look at 2 code snippets that I wrote to solve some exercises on the website exercism.io. Who's used this website for solving exercises? Yeah, so I love the exercises on this website. It's pretty popular. I'm not going to knock this website here. I'm not meaning to do that. But these exercises are made by whoever wants to make them. They're often transliterated from other languages where different styles of programming are more widely adopted. In Java, for example, you can't not make classes. Everything is a class. In Python, we do things a little bit differently, meaning it feels a little bit clunky sometimes to have classes everywhere. So exercism is wonderful. It does sometimes push you to write unfriendly code, depending on where the exercise came from. So this is a class. I wrote this code to solve an exercise called matrix. It represents a matrix. The class matrix accepts a string that represents that matrix. It's a string that it contains numbers that are separated by spaces and by new line characters. When we construct a matrix class, the object that we get back has a rows property on it. It's an attribute that when we access it gives us the rows of that matrix as a list of lists of numbers. And it has a columns attribute. That gives us back the transpose version of those rows, kind of the flipped version of those rows there. So this class here does not need to exist. The reason I say this is that we can replace this class for a matrix with rows and columns with 2 functions, matrix from string and transpose. When we call the matrix from string function, we call it the same way that we called our matrix constructor before. We constructed a matrix object, but the thing that we get back is a list of numbers. We essentially get back our rows that we got before. If we pass that list of numbers to the transpose function, we get back the transpose of that list of numbers, which is the same as the columns that we had before. So we just replaced a class with 2 functions. Now, I prefer to do this. If we have a class that only has a few methods in it, and we never really call those more than once, it should be functions instead, probably. You might be thinking, though, so what? We had a tiny class. We now have a couple functions. A slightly bigger example, a more contrived example even, but a slightly bigger one, is this exercise here, space age. So this allows you to calculate your age on a given planet, given the number of seconds that you've been alive, and the planet name. Or rather, we use that planet name in a method there. So we can use this space age class by constructing it, passing in the number of seconds that we've been alive, and then calling methods on it. For example, we can call on Earth to get our age on Earth, or Mars, or on Mercury. This is another class that does not need to exist. We don't need a class to do a verb-like operation. There's not data here that really needs to be stored in this class. We've got functionality. We don't really have data that needs to be coupled to it. We don't need a class. We could replace this whole class with 1 function. This age on planet function accepts the number of seconds that we've been alive for and the name of the planet, and it returns our age on that planet. Just as before, we can get our age on Earth, on Mars, or on Mercury. But we don't have to construct a new class instance to do it. You do not always need classes. Friendly classes are great, but the friendliest code sometimes doesn't have classes at all, or it has few classes. So when making classes, I would like you to consider whether you even need a class, because you often don't. There's a talk on this subject that I would recommend called Stop Writing Classes. I see a few of you nodding your heads because this sounds familiar. I'd highly recommend this. If you didn't like this talk, it doesn't matter, watch that talk. If you do decide that you do need a class, you should make it a friendly one. Using your class, if another person is using your class, it should almost feel as natural as using one of the built-in classes in Python. Using lists, using dictionaries, using tuples. It should feel natural and easy to use your class. Creating a friendly class involves writing a lot of boilerplate code, though. But data classes, the data classes library that's built into Python can help you with that. If you're on Python 3.7, you get it out of the box. If you're on Python 3, you can pip install it. If you're not on Python 3, or you need some more features than data classes provides, you can always reach for the attrs library. So I would love to help you improve your Python skills. That's what I do for a living. Feel free to find me in the hall or chat with me at my booth if you'd like to talk about that later, or if you'd like to chat about classes. Thank you. So as far as questions, I usually like to kind of huddle in the hall and chat with folks about things individually. If you do have a question that you think should be on video for some reason, I guess feel free to ask. Otherwise, let's go to the hall. Yep, one question. Yeah. So the question, if I understand it, is can you globally overload operators in Python the way you can do it in C++? Was that right? I don't believe that's the case. If you could, you would monkey patch the object, but that would be a bad idea, and I don't think it's possible. But I might be wrong about that. If there's a core developer in the room, maybe you could correct me, but I'm pretty sure you can't globally override. Now, you could sort of get that behavior by making a mix-in, meaning because you can do multiple inheritance in Python, which is a whole can of worms that we can talk about in the halls maybe, and you could inherit from all your classes with that object. But yeah. All right, let's do questions in the hall.